In this video, I want to talk a little bit about using the Lattice package in R. The way that you use the Lattice package is a little bit different from, say, the base plotting functions that you use in the base plotting system. And so I want to talk a little bit about how you kind of write the code to make the plots that you want to use. When using the Lattice package, it's often useful to have a separate editor open to write code because the function calls to the Lattice functions tend to be a little bit more involved. And it's hard to fit them all, or it's a little inconvenient to fit them all into a single line. In the base graphic system, a lot of times you're calling single functions, and you're calling a whole bunch of functions to make a single plot. In the Lattice package, you're usually just calling one or maybe two functions, and the one function call will set up the whole entire plot. So often you'll have a really long function call, and it's easier to have an editor window open to write all that code. Here I'm using RStudio, and in the upper left I've got the editor window, and in the bottom left here I've got the console. Other programs are fine for using a text editor if you want, if you just want to use the standard R console. But RStudio is actually quite helpful for this kind of thing. So the first thing you can do is load the Lattice package like this in the usual way. Excuse me. And if you want to take a look at some general information about Lattice, you can say package Lattice, package question mark Lattice, that is. At least in RStudio over here, you'll see a nice little description of the Lattice package with some general information, some references, and some links to all of the functions in the Lattice package that you may want to look at. The most important function in the Lattice package really is the XY plot function, so I'll click on that here. And the XY plot function gives you a long list of arguments and options that can be passed to the function and a description of all those arguments. So I'm going to move on and start plotting some data. So the first thing I'm going to do is going to see what's in the Lattice package here. And you can see that there are a number of functions and data sets available here. And the one data set we're going to look at is the environmental data set here. So I'm going to load that data set for us to use here. So I'm loading the environmental data set. And of course, you can always get the help page for each data set. So you can take a look at that here. And you can see it's environmental conditions in New York City in May to September of 1973. You have information about ozone, radiation, temperature, and wind. So and of course there's other variables for the dates. So we've loaded this data set here. So let's just take a look at the first couple rows here. You can see down at the console here the ozone, radiation, temperature, and wind variables. And so I'm going to make a simple scatter plot of ozone and radiation. So the way you do this is with the XY plot function, and it's backwards from the usual plotting function. So instead of doing X and Y, you're going to do Y tilde X. So on the Y axis I want ozone, and on the X axis I want radiation. So I'm going to do it this way here. So it's kind of like a response and a predictor. And then you also have to give it a data argument, which tells the function xyplot where to find the variables ozone and radiation. Because ozone and radiation are not objects in my workspace, they are variables in this data frame. So what xyplot will do is it will look up those names inside this data frame. Okay, we'll close that. And you can see that the function's called, and the plot appears on the right here. And it looks like a standard scatter plot, nothing, maybe a slightly different from the usual plotting function. And you can see that actually a lot of the spacing has been arranged for you, so the plot goes more or less to the edges. It doesn't waste any space on the edges, and you don't have to set any spacing options. So I could have done something like XY plot and then added a little title to it. So maybe I'll say main equals ozone versus radiation. And if I run that, you'll see that the plot is made, but the title is added to the top. And notice that the plotting region was squished down just a tiny little bit so that the title could be fit into there. But just only enough room was made to create the title so as to not waste any space. Okay, so there's another variable here which is temperature, so I could plot temperature here. Um, and this is what it looks like here, so nothing special. But of course, one of the things the lattice package functions excels at is allowing you to plot kind of multivariate or lattice or type plots, so which allow you to look at the relationships between variables when you condition on the levels of another variable. So, for example, in this plot up here, we looked at ozone and radiation. One of the questions you might want to know is whether or not the relationship between ozone and radiation changes as the temperature changes. So first thing you'll notice in this plot is that there's kind of a cone shape to it, and as the radiation increases, the variability in ozone seems to increase. So one thing that may be going on is that there's an interaction with the third variable, maybe temperature, which modifies the relationship between ozone and radiation in the background. And so we can plot the relationship between ozone and radiation for different values of the temperature variable to see if that relationship is changing with temperature. So so temperature is a continuous variable, as you'll see here. Um, So you can't exactly condition on the levels of temperature because there are theoretically infinite number of levels of temperature. So what we're going to want to do is cut the temperature variable into a few different ranges, and then we'll plot the ozone and radiation relationship within those ranges of temperature. So I'm going to create another variable here called temp cut, which is going to be I'm going to use the equal count function on the original temperature variable. And what I'm going to do is going to create four different ranges of the temperature of the original temperature variable, so that and so that I can use this in my plotting. So when I call this and I print out the new variable, you'll see that what it does is it creates what's called a shingle variable, and the shingles here are different intervals that are slightly overlapping. So you see the first interval goes from 56.5 to 76.5 degrees Fahrenheit, and there are 46 observations in that range. And then the next shingle goes from 67.5 to 81.5, and there's 51 observations in that range. And you can see that the first range and the second range overlap just a little bit, and then in the third range, which overlaps with the second, it's 75.5 to 86.5 degrees Fahrenheit. Again, there's 51 observations, and then the last shingle also has 51 observations. So this function created four ranges of the temperature variable, all of which overlap slightly, and have roughly equal numbers of observations in them. So now what we're going to do up at the top here is I'm going to plot the ozone and radiation data, but I'm going to condition on the ranges of this temp variable. Okay, and so now what you'll see is now I've created a lattice plot here where each of the four plots here plots ozone versus radiation, but for a different range of temperature. So on the bottom left over here, there's 46 observations here. I'm looking at ozone and radiation for the kind of range of temperature that's between 56.5 and 76.5 degrees Fahrenheit. And you can see actually that there's almost no relationship between ozone and radiation in this temperature range. This is a fairly cool temperature range. So one thing that we know about ozone is that the production of ozone is related to the temperature. So the warmer the temperature, the more ozone you're going to get in the atmosphere. So perhaps we should expect that in the cooler range of temperature, we're not going to see much of a relationship between radiation and ozone. Now in the second range here, we see that there is not much of a relationship between ozone and temperature, though there are a few outliers here. And then as we increase the temperature in the third plot here, up on the upper left, you see that there's an increasing relationship with radiation. And then in the fourth plot here, you see even more of a relationship between ozone and radiation for the last temperature range, which is between 80.5 and 97.5 degrees Fahrenheit. And so the XY plot function is useful for making these kinds of conditioning plots, where we plot the relationship between two variables and condition on the levels of a third variable. In this case, the temperature variable, which we've cut into four different ranges. There are a few other things that we can do to this plot just to rearrange it a little bit, just in case you don't like the default layout. For example, we can change the arrangement of the plot. So the default arrangement goes from the bottom left to the bottom right to the top left to the top right. If you don't like that, you can change it so that, for example, we can have four on top of each other. So we can say layout is 1 4, and then when we do this, you'll see that there are four different plots all on top of each other. And now you can see perhaps a little bit more clearly that the ranges of the temperature are overlapping slightly, and roughly speaking, kind of how they relate to each other. We can also change the order in which the plots are drawn. So instead of for example, from bottom to top, which is the default, we can draw the plots from top to bottom by simply adding the as.table argument, saying as.table equals true, and that will give us the reverse order. So now you can see that the plot for the bottom temperature range is is on the top, and the temperature increases as you go down. You can do this also without, if you like the original layout with the four plots as in a square, you can do that, and now you can see that the plot goes from the top left down to the bottom right. Another thing that might be useful to do for visualization purposes is to actually plot the relationship between solar radiation and ozone within each of the panels. And the way we can do this is to write our own panel function here. So what I'm going to do is I'm going to edit this call here. I'm going to add my own panel function here. So, and I'm just going to do add this. So the typical panel function has x for the x coordinates and y for the y coordinates. You can think of these as the x and the y coordinates for each panel. So the same function is going to be applied to each panel, and so it has to work for the data in each of the four panels. And then the dot 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 argument is all the other graphics parameters that would normally be passed to the default panel function, which I'm not going to modify at all. So now I've got my now I'm going to write my custom panel function, and the first thing I'm going to do is call the default panel function. And the reason why is I want to be able to set up the plotting region. I want to be able to set the plot symbol, the colors, the labels, everything. None of that is something I want to change. All I want to do is add a regression line to the plot. So now I've got my plot set up. I can fit a simple linear regression model, which is using the lm function of y tilde x. And then I can add the line to the plot with the panel.av line function and just give it the fit output from lm. And that's it. So that's my custom panel function here. So now I'm going to run this whole block of code. Excuse me. And when I do, you'll see that in each of the panels, a regression line is overlaid onto the data, which is the kind of the regression fit to the data within that panel. And as you can see, the regression line is relatively flat in the upper left panel, and as you go to the upper right, to the lower left, and then to the lower right, the slope of the line is increasing as you go along. You can use some of the standard plotting options if you want to modify the plotting within each panel. So, for example, if you want to make the line a little bit thicker, you could say LWD is equal to 2. And maybe, let's say you want to change the plotting symbol to be a solid circle. So I could just, in the call to XY plot, to say PCH is equal to 20. That'll give me a solid circle. So now I'm going to run this code. And you'll see that the plotting symbol has changed and the regression line is a little bit thicker. And so you can modify this until it looks the way you want it to look. You can see why you might want to use the text editor now when you're using the Lattice package, because the function calls to things like XYPlot can get very quickly complicated just because you're customizing things and you're adding your own panel function and whatever, all to the same function call. So I'm just going to add maybe just one modification here. Instead of doing a linear model, I'm going to use a low S, which is just a smoother. So I can do panel low S here on XY. And that'll give me a smooth rendition of the line. So now you can see that actually in the lower right, which is for the high temperature range, the relationship appears to be a little bit nonlinear there, which is an increase with radiation, but then a decrease at the very end. I can Also, just change the labels on the x-axis. So maybe on the x-lab, I want to say solar radiation, and then on the y label, I just want to say ozone, maybe in parts per billion. So I can run this code now. Let me just add a title. And I can put this on the next line here. So now I can run this code again. And you can see that the margins and everything gets adjusted so you're able to fit the labels onto the plot. And so you don't have to worry about things like spacing. Finally, I just want to show one more example of how you can look at interactions in R. So there's one more variable in this data set, which is the wind variable. And so we can look at how ozone and solar radiation vary with both temperature and wind. And so I'm going to cut the wind variable into, again, 4 parts with the equal count function. You can see we can just take a look at this new variable here, and you can see that there are 4 intervals and they do overlap, and they're roughly equal count within each interval. So now I'm going to take my original code here, paste it in, but now I'm going to plot the relationship by range of temperature and by range of wind. And so we can run this code now, and we'll see what happens. And so now you can see that actually there's 16 plots now instead of 4, which makes sense because there's 4 different levels of temperature and there's 4 different levels of wind. So the combination of the two together has 16 possible combinations. So you can see on the upper left here is for when wind and temperature are in the low range, and all the way down here at the bottom right is when wind and temperature are in their high range, and everything else in between is for some combination of wind and temperature in between. So you can see that you can see how the relationship between solar radiation and ozone changes for different combinations of low wind, high temperature, low temperature, high wind, etc., or maybe medium wind and medium temperature. And you can see that the relationship is perhaps most interesting for the kind of high temperature and then maybe low to moderate wind. In this upper right corner over here, you can see there's an interesting nonlinear relationship there between radiation and ozone. And so you can see that for each of the two conditioning variables, wind and temperature, there's a little highlight slider that shows kind of where you are on either the wind or the temperature range, whether you're low or in the middle or you're in the high end. And so that helps you kind of see where you are in the range of the conditioning variable. So these things can all be kind of customized if you want in terms of the colors and the labeling. But by default, you can see that the XY plot function will use the name of the variable as the label within the strip up here. So that's a very quick demo of the XY plot function in Lattice. There are a few other handy functions in the Lattice package that of course you can use and may find handy. So one of them is the scatterplot matrix function, or the SPLOM function. So you can use the SPLOM function to look at pairwise relationships. So you can do SPLOM, and then you give it a tilde, and then you can give it the entire data set if you want to look at all possible combinations in this data set. And when you run that, you'll see it makes scatter plots of all the different variables against each other, each one plotted in 2 different forms. You can also look at histograms with the histogram function. So you can look at histogram of, let's say, a single variable, let's say temperature, and give it data equals environmental here. And when that runs, you'll see a histogram of the temperature variable here. So that's pretty standard. There's nothing particularly special about that. But again, you could look at something like temperature, a histogram of temperature as the wind varies. So I can use my wind.cut variable and then plot a histogram of temperature for each range of wind. You can see that the distribution of temperature doesn't change too dramatically as the wind changes. But another thing we can do is say look at the histogram of the distribution of ozone as the wind changes. and see if that is anything interesting. And you can see that as the as the wind increases, the ozone is a little bit more concentrated in the lower range, whereas when there's very little wind, the distribution seems to be spread a little bit towards the higher range. So the distribution does appear to change a little bit with wind. So that's the histogram function, which can be used in very much the same way as the as the xy plot function, excuse me, where you can condition on different variables. Of course, we could condition on both temperature and wind to see what the distribution looks like when you condition on those two variables. And you can see that as wind and temperature changes, the distribution does become more spread out or more concentrated towards zero depending on which way you're going. So in the bottom right over here, we see that when there's very low wind and very high temperature, the distribution is most kind of spread out towards the higher range. Whereas when there's very high temperature and very low wind, when there's very high wind and very low temperature in the upper left, most of the values of ozone are concentrated around zero. So that's the histogram and scatterplot matrix function, and as well as the xy plot function. So these are just a few of the functions in the Lattice package that can be used to plot data, and more importantly, to plot conditional relationships of data in a way that's very compact and very useful to visualize.